Hi, welcome to our math. Today I'm doing a series of videos on inequalities and the absolute value of inequalities. Here we have two problems, and the first thing I want to note is with inequalities, before we can do any of the steps with breaking up the absolute value part, the absolute value has to be isolated. In these two problems they are, so we can go right ahead with the next step. But if there was a plus or minus or a number multiplied outside, we would have to deal with that first. Okay, so since we're fine, we're going to go to the next step, which is absolute value is a V graph. It looks like this or it looks like this, which means there's going to be two answers to my problem. So to get that, what I'm going to do is I'm going to write 6x minus 5 over 2 is greater than 7. That's one of my answers, just like the problem is written. But the thing is, when this number comes out, if it were a negative 7, it would also work. So I'm going to say 6x minus 5 over 2. I'm going to flip both of these. Could also be less than negative 7. So to deal with the absolute value, you write it just as is, but then you write it and you flip your inequality and you flip the sign on the isolated number or whatever is on the other side of the inequality. So I'm going to multiply both sides by 2. So I have 6x minus 5 is greater than 14. I will add 5 to both sides. 6x is greater than 19. Divide by 6. And x is greater than 19 over 6. I did this pretty fast. I've been having a lot of negative numbers where you flip your inequality sign, but I do want to slow down and note that if you're not dividing by a negative, you don't flip your inequality sign. So because the 6 is positive, the inequality sign just shot right down. That inequality just stayed as is, step by step. I brought it down as a greater than sign, as a greater than sign. That greater than sign maintained its greater than status step by step in this problem. Over here, same thing's happening here. I multiply by 2. I don't care that the 7 is negative. I care that the 2 is positive. Because the 2 is positive, I'm going to have 6x minus 5 is less than negative 14. It doesn't matter where we're going. It matters what we multiply by 2. That negative less than sign stayed less than. Add 5 to both sides. The less than sign will stay. 6x is less than negative 9. Divide by 6 to both sides. The only thing I have to do here, I don't need to change my sign. It will stay less than. X is less than. I do need to reduce my fraction. I want my fractions reduced and improper. I can take a 3 out and have negative 3 halves. So the only thing I had to do on this problem, my inequality signs stayed as they were throughout both sides. I did need to reduce my fraction. That was important. Okay, this one I didn't need to reduce because 19 over 6 was not reducible. I put the negative 3 halves over here because that's closer to negative infinity. I'll put this 19 over 6 here because that's positive. Let's see. X is greater than that, so that's going to be over here towards positive infinity. X is less than this, which is over here towards negative infinity. That's why I like to put the positive and negative infinities in. Just remember, if X is by the pointy end, that means less than. And if it's by the big end, it means getting bigger. The parentheses are the same as the less than and greater than. The brackets are the same as the less than or equal and the greater than or equal. So because this is without the equal sign, I'm going to use the parentheses. And to write this answer in interval notation, I'm going to say negative infinity to 3 halves. I'm going to use the union, which is a capital U. You can think of it as joining these two parts together. 19/6 to positive infinity. So negative infinity to negative 3 halves joined with 19/6 to positive, or negative infinity to negative 3 halves union 19/6 to positive infinity. All right, so for the second problem, it's similar. The first step is to write it exactly as is. 5x minus 3 is less than or equal to 18. Then I write it again, changing the tail half. 5x minus 3 is greater than or equal to negative 18. All right, I'm going to add 3 to get 5x is less than or equal to 21, and then divide by 5 to get x is less than or equal to 21/5. Add 3 to both sides. And again, bring this inequality down. 5x is greater than or equal to negative 15. Divide by 5. X is greater than or equal to negative 3. I didn't flip my inequality because though the 15 is negative, I divided by a positive 5. You only flip the inequality if you multiply or divide by a negative. It doesn't matter what you're dividing into. It only matters what you divide by. So if I come and graph negative infinity, positive infinity, I have a negative 3. I have a positive 21/5. Let's see. X is less than the 21/5. It's greater than the negative 3. They both have the equal signs. That means I'm going to use those brackets. So my interval notation is going to be negative 3, 21/5. Okay. I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thank you.